All right, you guys. Question 3. One thing it didn't tell you on question 3, or it didn't make very clear, was the difference between profit and revenue. So it kind of does everything in revenue, but it's asking you for profit. So just be careful. It's asking you for profit. So what we have to do, profit is your revenue minus the cost. So profit is what you take home minus the amount of money that you had to spend for something to happen, right? So we have a probability table here, a little distribution. So the first thing I did is it says, what is the expected profit for a show? So what I did was I found the expected value or income from a show, and then from that I subtracted the cost for one show to get our profit. So what that looks like is using the expected value formula, which is we just did it in one or two problems before. So you take the revenue, so we take 2 million times 10% probability you'll make that much, plus 1 million, and there's a 40% probability that you'll make that much, plus 500,000, there's a 30% probability you'll make that, plus 100,000, there's a 10% probability you'll make that. And there's a 10% probability that you won't make anything at all, which would suck. So we find all of that, and if you use that formula, or if you just put it into the calculator like we did in the video before this, you would get your expected income, your expected value, to be 760,000. From that, we have to subtract the cost, 450. I highlighted it in the question above, 450,000, so that your expected profit would be $310,000. Question B is real simple. You can either multiply your expected profit by 6, or what I just did is I multiplied 6 times the expected value from one show minus 6 times the cost for one show. Either way you do it, you will get an average income of, or an expected income of, $1,860,000 a year. Question 4, you conduct a survey to view more or to learn more about the student body of CCD. You asked 500 students whether they have a family, spouse, and children, and how many credits they are taking. So we have this table. Question A, what is the probability that a student is without a family and taking 12 credits? So we're looking for just the probability of A and B. So our total sample is 500, and the probability of A and B is 113. So we take 113 over 500, and you get 0.226, or approximately 22.6% probability that a student is without a family and taking 12 credits. Question B, same type of math, but the question is asking what is the probability the student has a family and is taking 12 or more credits, and that would just be 68 out of 500, or 13.6%. Moving on, we're going to finish this question on the next page and maybe the next one. Question C, given that the student has a family, and this one's going to be conditional. So given that the student has a family, which I made as B, that this student has a family already. So our pool of people that we're going to choose from has already been whittled down to 217. And you can see that becomes our denominator here. Our numerator, because it's the probability of A given B, the probability of A being that somebody is taking 18 credit hours. So we're only choosing from those 217 people that have a family. And then our numerator becomes that box where they have a family and they're taking at least 18 credit hours. And that's only going to be 24. Okay, so your probability here is going to be 24 out of 217, or approximately 11%. D is the same type of math, except we are given, our B here, our given is that somebody's taking 12 credit hours, which is 181. So we're only choosing from that group of people, 181 people that are taking 12 credit hours, and we're looking for what's the probability that he or she doesn't have a family. So we need to choose, so 181 is our denominator, and the probability of A and B is what becomes the numerator, which is 113. 113 are all of those students who are taking 12 credit hours and don't have a family, right? And so if we're choosing out of those people taking 12 credit hours, there's a 62.4% chance that they're not going to have a family. Does this question make you a little bit sad? I feel like it has made me a little bit sad. I'm not crying, I just have a stuffy nose. Question 5, a couple decides to have children until they have one boy and one girl, but they will not have more than 3 children. The sample space of possible outcomes is, so it gives us a sample space here. They could have a girl and a boy, and then they'd be done. So they only have 2 kids. They could have a boy and a girl, then they'd be done. So they only have 2 kids. They could do boy, boy, girl, 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 boy. They could have all boys or all girls, which didn't give them what they want, but they had to stop because they had 3 kids. So question A says the couple only has 1 boy, and there was 3 out of those 6 that were in the sample space, so that's 1/2. I guess we didn't really need to know these. They just wanted us to look at it, but I went ahead and did the math for you there. Determine if the following pairs of events are disjointed. So disjointed means they are mutually exclusive, okay? A and C, A, the couple has 1 boy, and C, the couple has 3 children. That's not disjointed because they could have overlapping there, right? You could have girl, girl, boy, and that meets both A and C, right? A and D is disjointed because the couple has 1 boy, and D, all of the children, the couple has 1 boy, and all of the children are the same gender. Cannot happen because there's not, where you only have 1 boy and they're all the same gender. That cannot happen, so that's disjointed. Or that cannot happen at the same time. C and D is not disjointed because the couple has 3 children and all the children are the same gender. Well, that happens twice, so there's a little overlapping there. Question 6, scores on a certain test are normally distributed with a mean of 77.5 and a standard deviation of 9.3. So I went ahead and drew the normal curve. You don't have to do this whole thing. I just wanted you to see it. There's my mean. If I add 9.3 once, I get 86.8. If I add it twice, I get 96.1. Add it 3 times. Subtract 9.3, subtract 9.3, subtract 9.3. So there's my normal curve given this spread. What is the probability that an individual student will score more than 90? So you just need to use your normal CDF, where your starting value is 90, your ending value is positive infinity, your mean is 77.5, and your standard deviation 9.3. And there's your probability right there, approximately 8.9%. What proportion of the population will have a score between 70 and 85? So I just did the same thing in the calculator. And this time my starting value was 70. And if you need to go back through this for the homework, I really went over how to use the calculator for this, I think. Your starting value is 70 this time, your ending value is 85. We want what's in between there. Here is your mean, and your standard deviation stay the same. So that's approximately 58%, which makes sense, that middle piece. And this time we're doing it the opposite. Find the score that is the 80th percentile of all of the tests. So we want to know our area. If we're given our area is 80%, and this is our mean, and this is our standard deviation, what is that score that represents 80? And that score would be approximately 85.33. So to get to the inverse norm, you do second. I'll write it down here. The same place we've been going for a lot of this stuff. You do second vars, which gives you distribution, and you arrow down. I think it's only 3 this time to the inverse norm. And then your calculator should ask you these questions and then enter, and you get your answer. Is that the last one?
For question 6, yep, I'm going to stop this video here.